This is section 5.3, and we're going to solve systems using substitution. Let's take a look at number 1. Notice that we have two linear equations. They're terms of x and y. We could graph those like we did in 5.2, but here we want to solve them algebraically. And so the first method of solving I'm going to teach you is substitution. Notice that the second equation is already solved for y. And so what we are going to do is take what this equation is equal to and replace y in the first equation with it. So I'm going to rewrite my first equation exactly as it was, except for instead of writing y, I'm going to write what y is equal to in terms of x. Y was equal to x plus 2, so I'm going to replace y with that. Now I have one equation in terms of one variable. Let's go ahead and combine like terms, get our variable alone, and solve. Now I have x equals 2. Now I'm not quite done because I also need to know what y is equal to. And I'm going to come over here and in my y equals equation, plug in what x was equal to. And now I have a solution. Graphically, this solution would be the point where x is 2 and y is 4. Let's move on to number 2. Which equation in number 2 is already solved for one variable? Hopefully you'll agree with me that it's the top equation. That means that down here in the bottom of the equation, we are going to replace y with what it's equal to. So now I'm going to have x, and instead of times y, times what y is equal to, 4x, equal to 36. Now when I multiply the left hand of that equation, I get 4x squared equals 36. To get my variable alone, I'm going to divide both sides by 4, and I get x squared equals 9. Finally, I need to square root, which means I get not one solution, but 2. And when I square root, I should get both a positive 3 and a negative 3. Those are my two solutions for x. And when I plug those solutions back in for x to find y, when x is a positive 3, I get 12. And when x is a negative 3, I get negative 12. So these are my two solutions, and graphically these would be the points 3, 12 and negative 3, 12. What I would like to see on your homework is solutions just like we found in section 5.2, where we're showing graphically what those points would be. All right, if you're brave, go ahead and put the video on pause and try number 3 on your own before we do it together. All right, hopefully you realize that y is already solved for itself in equation number 1. It's equal to 4x minus 3. And so in my second equation, I am going to replace y with 4 minus 3x. Sorry if I said that wrong a second ago. Now I want to combine like terms. And I have these two variables are canceling. Oh no. Does 4 ever equal 7? Not under any circumstances. Not ever. So what is my solution? I don't have any. I know it was kind of mean to make you try that one on your own. If your variables cancel and you end up with a false statement, you have no solutions. If your variables cancel and you end up with a true statement, your solutions are all reals. All right, let's try number 4. Let's plug in y as 2x squared into equation number 2. And what do you notice here? Here I get 6x squared. I could divide both sides by x squared to get rid of it. And notice that now I have a true statement. Does 6 equal 6? Absolutely it does. It always equals 6. So how many solutions do I have? Well, my solutions are all reals. That means that these two equations are essentially the same equation, and thus every solution on them will map to the other. Let's see number 5. Or let's see. Actually, number 5 is the one I want you to try for your own. I would like you to give an attempt on number 5. Come in with a solution in point form for me tomorrow morning, and I'll see you then.